Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 169. Please turn to it. Page number 169, and today is our lesson number 7. Let's take a look at the very first problem. The very first problem is actually a very silly problem. They're simply asking us, very first problem number 21, they're simply asking us which is equal to x over y. Which one of the quantities that they give us happens to be equal to x over y? Answer choice A says x times z over y times z. Well, if you divide top and bottom by z, we get rid of the z. And there we go, it is x over y. The answer is A. As I said, it's very silly. Let's do the next one, shall we? Question is, what is the slope interpretation of the... Well, let's put it down on the blackboard here. What is the slope intercept form of 8x minus y minus 6 is equal to 0? What is the slope intercept form of the given equation? 8x minus y minus 6 equals 0. Now we know the slope intercept form. If you're looking for the equation in this form, slope intercept form, it looks like this. Y has to equal to mx plus b, where m is our slope, and when x is equal to 0, the value of the y is b. When is x equal to 0? X is equal to 0 along y-axis. So this represents the y-intercept. For example, if line is going like this, then this height that we're showing here is your b. Thus, when x is equal to 0, y happens to be b. For another line, for example, here, the intercept would be negative here, and so on and so forth. So that's your intercept, that's your slope. In other words, somehow we have to convert this thing into this form, which is very simple. All we have to do is bring the y to that side. That's it. Bring the y to that side. How do we bring the y to that side? Well, let's add y to both sides of the equation. If we add y to both sides of the equation, negative y is going to kill the positive y. What we end up here is 8x minus 6 equals y. And of course, that is the same as saying y equals 8x minus 6. Our slope happens to be 8. And the y-intercept happens to be negative 6. But anyway, that's your slope intercept form. Whichever answer choice agrees with that, 8x plus it should be 8x, not plus, 8x minus 6, sorry, not 8x plus 6, 8x minus 6. I almost made a boo-boo, and the other answer choice would be what? 8x minus 6 is answer choice. Listen, I'm not going to waste time looking for the correct answer that matches here. That's the answer, 8x minus 6, whichever answer choice agrees to is, that's the answer, okay? Let's do the next one, shall we? You can do the matching of the letters yourself. The next one, that's it, we are done with this one. And that is known as the slope intercept form of the equation. Question number 23. Which of the following is the solution to the equation? So we're looking for the solution to the equation. This is number 23. Solution to the equation x squared minus 36x equals 0. Well, x squared minus 36x equals 0. What do we notice right away? This is x squared, which is x times x minus 36x equals 0. What do we notice? We have a common factor. We have a common factor of x. We can take out this common factor of x as a common factor, obviously. And once we take that out, what are we left with from the first term? From the first term, what are we left with if we take out 1x common? we're left with x. Because x times x is going to give us our x squared. And here, once we take out the x common, we're left with negative 36. Because x times negative 36 is going to give us negative 36x. We're almost there. So here we have two quantities. This is one quantity, this is another quantity, x minus 36 another quantity. So if we are told that a times b equals 0, if we are told that a times b equals 0, what do you surmise from that? What do you gather from that? What do you infer from that? If you are told that a times b equals 0, what do you surmise from that? What do you infer from that? What do you gather from that? Well, we gather that if the product of two quantities is 0, then there are only two possibilities. Either a is equal to 0 or b is equal to 0. As a matter of fact, now that I think about it, there are not only two possibilities, there are actually three possibilities. Either a is equal to 0 or b is equal to 0, or they are both equal to 0. 0 times 0 is also 0. So it doesn't matter what b is, as long as a is equal to 0, 0 times b would be 0. Or if b is 0, it doesn't matter what a is, because a times 0 would be 0, or maybe they are both zeros. That's what we're going to talk about here. So we have two quantities, x and x minus 36, which means either x is equal to 0 or x minus 36 is equal to 0. If x is equal to 0, then x is equal to 0. That's your solution. X is equal to 0. Is 0 one of the answer choices? If 0 is one of the answer choices, we are all done. Number 23. 0 is not one of the answer choices, so we have to look at the second solution. Second possibility is that maybe this quantity is equal to 0. X minus 36 is equal to 0. If that's the case, if that were the case, that implies that x is equal to positive 36. That's it. That's your answer. X equals to 36 is the answer. That's the solution that they're looking for. Do you understand? That's all. What number was this? This was number 23. Let's move on then. 24. 24, just give me 1 second break, which is actually 5 seconds long. Okay, 24. In 24, we're given a triangle that looks something like this. A triangle which is R, S, T, and the opposite sides are denoted with a small letter T. A side facing point S is the side with a small s, and the side facing point R is a small r. And what they're looking for is the tangent of R. Tangent of R. Right here. And tangent, of course, we know is opposite over adjacent. And how do we know tangent is opposite over adjacent? Well, we have a mnemonic device which is so ka to a. Sine is, this mnemonic device tells us the sine is hypotenuse. This is wrong. What the hell? Sine is opposite over hypotenuse. So cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Opposite over adjacent. So what is the side that is opposite to point R? The side that is opposite to point R is this side, which is R, and the adjacent side that is adjacent to it is this side, T. There you go. Tangent of R is R over T. It's R over T. Again, whatever letter that happens to be. R over T is answer choice G. Let's do the next one, shall we? The very last one on the page, number 25. Number 25. Very good. We always pause for 5 seconds between the problems to give you the unobstructed view of the blackboard and to give you enough time to pause and unpause the video if you need to. Number 25. We are given a circle which looks something like this. And we have a line that goes something like this, which they did not name, but I'm going to name it. Let's call it A to B. And then we have, is that point supposed to be the center? A chord 24 inches long and 5 inches from the center of the circle. Yes, it is the center. This is the center. And this is 5 inches. Let's call this center C. Why not? We are creative people. And so AB is the chord. That's what it's called. It's called the chord. If the line does not go through the center, if the line goes through the center, of course, that's the diameter. But if it doesn't go through the center, it's called the chord. This is a chord, that's the chord, this is a chord. These are all chords. These are called chords. AB is a chord because it doesn't go through the center. And we are told it is 24 inches long. AB, we are told it's 24 inches long. And because this is in the center, it's going to bisect this distance A to B. Bisect means it's going to cut into equal parts, which means from here to here it's 12, and then from here to here it's 12. Let's give it a name instead of saying from here to here. B to B is 12. And what exactly are they asking for crying out loud? How much is radius? How much is radius? Well, radius is from the center to this point right here. Anywhere you go. So this is what we're looking for. This is the radius. Do you see anything here? Let's redraw this thing. Let's redraw this triangle in the bottom here to see if you can see something. This is the right angle. This is the right angle right here. This is the 5. This is our point C. This is our point D. This is our point B. From D to B is 12, we are told. And the question is, how much is the radius? Do you notice anything? Again, yesterday we talked about a special triangle called a 3, 4, 5 triangle. Another triangle that you have to learn to recognize in the exam is what is known as a 5, 12, 13 triangle. 5, 12, 13 triangle is what we're dealing with. 5, 12, 13 triangle. If you can recognize a 5, 12, 13 triangle, it will save you a great deal of time in some cases. And if you don't recognize this, it's not the end of the world. It's very simple. Just square 12. 12 squared is 144. 12 squared is 144. The square of the 5. 5 squared is 25. And of course we get 169. And I hope that you know your squares. You have to know your squares 1 through 20, or at least 1 through 15. You have to know 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared. So you have to know them by heart. And if you do know them, if you did know them by heart, you will recognize then 169 is simply 13 squared. That's all. That's why it's 13. Why is 13? Because 13 squared happens to be equal to 5 squared plus 12 squared, which is the Pythagorean theorem. But we wouldn't have had to do all this work. We wouldn't have had to do all this work had we been able to recognize immediately that it's a 5, 12, 13 triangle. Do you understand? That's all. Let's do one more 5, 12, 13 triangle, shall we? Let's do one more. I'm going to do it on this side here. A 5, 12, 13 triangle incognito. So here's your triangle. We're going to make it very simple. This is 36 and this is 15. Can you tell me what this missing side is? Again, before you do any work at all, check. It's a right angle triangle. Okay, compare yesterday's video to today's video that you're watching right now. And if you have not watched yesterday's video, go back and watch it. And yesterday's video, what we said was this. Yesterday's video, what we said is that if you're given a right angle triangle, and if you're given two sides, and we are being asked to find the third side, which is exactly what this is here, stop and ask yourself first, is there a 3, 4, 5 triangle? What is this, a 3, 4, 5 triangle? Well, in order for it to be a 3, 4, 5 triangle, the smaller side would have to be a multiple of 3. Well, it is a multiple of 3. This is 3 times 5. This is a multiple of 4. But it is a 4 times 9. It doesn't work. It's times 5 and times 9. So it's not a 3, 4, 5 triangle. We're not dealing with 3, 4, 5 triangle here. The next thing that you ask yourself, the next thing that you check before you do any work is, ask yourself, is there a 5, 12, 13 triangle? That's another triangle that they like, another triangle that they love, 5, 12, 13 triangle. Let's check it, shall we? 5, 12, 13 triangle, in which case 15 would have to be some multiple of 5. 15 is a multiple of 5. It is 5 times 3. This would have to be 12 times 3. Well, it is 12 times 3. 12 times 3 is 36. Well, if it is 12 times 3 and this is 5 times 3, then the missing side would have to be 13 times 3. The missing side is 39. You don't have to do any work at all. It's a 5, 12, 13 triangle incognito. You understand? Oh, I erased it from yesterday. Incognito was the word that we learned on day 42, I believe, in our vocabulary lessons. Incognito. Not day 42, it was day number, I'm going by my memory here, it is 42. Incognito. Day 42 in our vocabulary lessons is when we learned it. Just type in ACT vocabulary words, day 42, and the video will pop right up. Do you understand? I'll see you tomorrow, okay? Bye now.